Hey everyone, in this lecture we're going to become introduced to the C programming language, which ultimately, when compared to an assembly language or machine language, will provide us with a simpler means for specifying that a microprocessor perform some set of operations. So let's get right into the lecture. The following is going to be covered within this lecture. First, some motivation for a programming language other than an assembly or machine language. Second, a brief introduction to the C programming language. And third and finally, a listing of some useful resources for learning how to apply the C programming language. Thus, you should note that this lecture is not a tutorial on how to utilize the C programming language. Such instruction should be sought throughout other content. To have some motivation for other forms of programming, let's first recognize the following. Although assembly and machine languages provide a programmer with some means for directly controlling the operation of a microprocessor, writing a computer program with such languages often requires a significant amount of effort. Overall, we can say that this is because these languages are often notably different than that of a natural human language. Thus, so that it would be easier for us to write computer programs in a more efficient and effective manner, it would generally be useful to have the ability to instruct a computing system via some more abstract, closer to human language. Well, fortunately, in the modern world, there already exist many computer programming languages, actually close to 1,000, that allow humans to communicate with computing systems in a more productive manner. Now, out of all computer programming languages that exist today, one of the most mature, well-established ones is the C programming language. Now, for an overall view, C is a simple, general-purpose programming language meant to provide a programmer with almost as much control over an underlying computing system as an assembly or machine language does. Really, this is C's main advantage over the hundreds of other programming languages that exist today. Other languages will generally sacrifice a higher level of control for more abstract or more specialized grammar, so that code may be written in a more simplistic manner. Now, with that being said, there does exist a separate programming language, C++, that provides in effect the same benefits as C and more in some cases, although it is not yet, but is close to being as widely supported as C. Now, overall, because of C's powerful nature and simply because C is so widely supported by computing system platforms out there, knowledge of how to utilize the C programming language is invaluable to most any computer programmer. For some of the remainder of this lecture, let's discuss how the C programming language will fit into some overall programming toolchain model, where the term toolchain here is meant to refer to some series of software tools utilized in conjunction. Now, on the right is some particular but partial depiction of the generic programming toolchain model we have utilized throughout this course thus far. Now, as an overview, application code was generally written in assembly language, where that code incorporated preprocessor or assembler directives whenever appropriate, and then that code with preprocessor directives was fed into a software tool known as the preprocessor, where the preprocessor would handle any preprocessor directives present, such as the definition or reference of some symbolic constants, or include statements that included other source code files, etc. And then the output of the preprocessor was some elaborated assembly source code files that only contained assembly code. And then that assembly code was fed into a second software tool known as the assembler, where the assembler actually generated machine code files for the relevant microprocessor architecture. And these files were generally object files, etc. And then these object files are then fed into another tool known as the linker, where generally we only had one of such files, but in general there could be multiple. And the linker actually performs any memory mapping of program code or other definitions in memory, etc., and links all of these machine code files into a single executable file, such as a .hex file, .elf file, etc. And then that file, whichever one was most pertinent, was programmed onto the microprocessor or into the microprocessor. Now, when using the C programming language, we're going to see here in just a second that the toolchain model we will end up utilizing will actually remain very similar, if not almost entirely equivalent, to the toolchain model we have utilized thus far throughout this course. Now, before I get into any details, let's first note that on the right is a new updated partial depiction still, but of a new generic programming toolchain model that we will begin to utilize when programming with the C language. Now, there's going to be a couple differences, but the main first thing I want to note is that most everything is going to be as it was before. Now, let's start by saying that now the main difference, the primary difference, is that our application code is going to be written with the C programming language. We're going to have this more abstract manner for describing our application in terms of code, but at the end of the day, we still want our microprocessor to be able to interpret machine code that is representative of our application code now described with the C programming language. So we need some way of translating C code to machine code, and we could maybe imagine that we could have a tool that directly translates from C code to machine code, but it will actually make more sense if we reutilize the assembler and linker tools that we did before, but instead of starting with assembly code, if we now start with C code, what if we could have a new tool, which is going to ultimately be known as the compiler tool, that translates our C code into a representative assembly code for our target microprocessor. And that's exactly what we're going to end up doing for our purposes and in general when you program with high-level languages. So we're going to have application code written in C, and then eventually that C code is going to get compiled, we're going to say, or translated into a representative assembly code, and then that assembly code, just as before, is going to get manipulated by the pre-existing tools that we discussed previously. So this is the first main idea I want to mention, and let's talk about a couple other things in the next couple slides. So with our code now going to be written primarily with the C programming language, hopefully it is somewhat easy for us to deduce that preprocessor directives will now also be primarily applied within the context of C code. Now, to understand this, let's remember that preprocessor directives were primarily to quote-unquote preprocess our code, anything meant to organize or anything similar to handle the code before the remainder of the tools within the toolchain actually manipulate and assemble our code, or now in our case compile our code, etc. So what this means is now our source code files written in C are actually going to have some form of preprocessor directives, where these preprocessor directives, instead of being called assembler directives normally, will be now usually called compiler directives or simply preprocessor directives. And now the preprocessor, still as before, will be the first tool in our updated tool chain, and then the output of that preprocessor will be still C source code, where that C source code now has no mention of preprocessor directives. It's, in other words, elaborated. And then that code then gets passed to the compiler, which then generates, as we said before, relevant assembly code, and then the rest of the toolchain takes over beyond that. So hopefully that makes sense with preprocessing. Now, another quick note to mention is that when programming with a C language, source code is to pretty much exist exclusively almost within files that have the file extension .c. And we see in this diagram here, I mentioned .h, but primarily we are going to store source code within .c files, and we're going to mention .h in the next slide right now. Now, the file extension .h is actually utilized by files normally within C programming contexts, but these types of files are almost exclusively used to implement what are known as header files. Now, header files, when utilized appropriately in conjunction with .c source code files, are used to implement some form of a modular or meaningful structure for some C program. Now, the manner in which this is normally achieved is by way of some clever use of preprocessor directives and some sparing amount of C source code. Now, I'm going to kind of leave it vague here for how exactly that's achieved, such a meaningful or modular structure for C programs, because in this course we don't really expect that you know how to create or thoroughly manipulate header files yourselves. But because of this vague notion, I'll at least mention that in general, structuring C code really is an art. It's not to be taken lightly. So if you're not already familiar with high-level languages or C in particular, do not expect yourselves to be masters yet to know how to appropriately or best structure C code. Now, to finish off this lecture, I just wanted to mention a couple helpful resources out there for learning C. Now, really, there exist many resources out there, probably thousands, if not tens or hundreds of thousands of resources for learning the C programming language, how to apply it, etc. Even tons for how to apply them directly to low-level microprocessors or microcontrollers, embedded systems, etc. But the primary ones that usually exist overall for learning C are the following two, at least in my mind. The first, which is more of a introductory or easy to read through source, is the C programming language book, specifically the second edition. And this book is written by Brian Kernighan and Dennis Ritchie, the second of whom is actually the creator of the C programming language. And this book, even the second edition, I don't believe there's a newer edition, was written, I believe, in the 80s or at least a long time ago. And that might seem like it might be like a turnoff to most people of choosing this as a primary resource. But even though the C language has evolved since this book, most of the same features of C or most of the same ideas of C are still well described within this book. So this is definitely a good resource that I even believe is free to see and read through online. You can find free copy, I believe, that's not illegal online. And the second source, which is like the go-to resource when you need to know exactly how something in C is supposed to be, is the actual standard, international standard be that, for the C programming language, which is known as officially the ISO IEC 9899. And this standard specifies and establishes the interpretation of programs to be written in the C language. It basically describes all of the core features and the specifics of C. So we're going to refer to this, or I'll at least tell you all to refer to this several times throughout the remainder of this course and some of these lectures. But when I refer to it, I would probably refer to the 1999 version of this standard, and that refers to the standard they created in 1999. Now, there does exist newer versions, I believe, created in 2011 and 2018, but most tools, if you're not already familiar with, it's hard for a lot of software tools, say like Atmel Studio or other IDEs, to readily support the newer versions. And C99, or the 1999 version of C, is actually one of the most common, if not most common, standards supported by tools out there. So that's generally the standard I'll refer to, and it does seem to be also the standard that's the easiest to find online too, at least from the little digging that I've done. So I'll just let you know that I'll primarily refer to that. But these two resources overall, very good to refer to. And I hope that they can find, or I hope that you all can get some help from those yourselves. So as a quick recap of what we've covered within this lecture, first we gave some motivation for a programming language other than an assembly or machine language. Then we provided a brief introduction to one of the most common programming languages, the C programming language. And then finally we gave a listing of some useful resources for learning how to apply the C programming language. So overall, note that this lecture has not been a tutorial on how to specifically apply or utilize the C programming language, and such instruction should be sought throughout other content. But I hope for an overall view regarding the C programming language, you all learned something from this lecture.